Hello, and welcome to another video lesson on how to use dimensional analysis in working out medical dosage problems. Now, this is the continuation of the video I started last time. So today we're going to look at some IV calculations. So the first question I want to focus on is the physician orders 1000 ml of Ringer's lactate to infuse at 125 ml per hour for post-operative patients if the tubing drop factor is 20 drops per ml. Calculate the flow rate in drops per minute. Okay. So let's annotate this problem. So first, we're given the order of 1000 ml to infuse at 125 ml per hour. Okay, so this is a given. And then you have the drop factor. And we want to find the drops per minute. So drops per minute, that means you want GTT per minute. Drops per minute. So let's see how we can arrange this using dimensional analysis to arrive at our wanted, right? So our wanted is GTT per minute. Okay. Now the given, let's break it down. So the given here is the order, right? So 1000 ml to infuse at 125 ml per hour. And then your wanted, what you want to arrive at, the wanted quantity. Is GTT per minute, drops per minute, and have your drop factor. Okay. So in this question, we're going to use the order that is given. Okay, we're going to focus on this, the 125 ml per hour. Okay, that is what has been ordered, all right? That's the rate the doctor wants, the physician wants. So let's begin with that. So write down 125 ml per hour, that means over 1 hour, times, which factor do we have to use here? All right, I want to get 2 GTT per minute. That means that I have to factor in my drop factor, right? So my drop factor will be here. Since I want GTT as part of the numerator, that will stay here. So 20 GTT will be here over 1 ml. Okay, so now I see I can cross out the ml. ml can cross out because I don't need it in the final unit. What do I have now? So now I have GTT, drops per hour. But the question says you want drops per minute. So what should I do? It means I have to change the hour to minutes. Okay, so I cannot do that. I know that we have 60 minutes in 1 hour. Okay, so since I want to cross out the hours, the hour will have to be in the numerator. So that's a conversion factor. So 1 hour is equivalent to 60 minutes. Okay, right? So the minutes is in denominator because I want the minutes in the denominator, drops per minute. Now what can I cross out? See, the hours will cross out. And then at the end, you see that we are getting the drops in the numerator and then the minutes in the denominator. Okay, so it means that our setup is correct. Now we can multiply this out and come out with our desired answer, which is GTT as per minute. Okay. So let's do that now. You can use your calculator to do this, or you can cross out and reduce to lowest terms. Okay. So let's multiply this out. So we have 125 times 20. All right, which is 2500, and then divide by 60. Okay. So that means that our answer is going to be 1.6 GTT per minute. Okay. Since we cannot have like a decimal in terms of drops, fraction of a drop, we run to the nearest whole number. So it means that we need about 42 drops per minute. Okay, so that will be our answer. All right. So dimensional analysis, as I keep saying, is an easy way of helping you understand and to do this type of problems with minimal error. Okay. Right, so let's apply this same thing, the same idea to this question, second question. We say the physician orders 1000 ml of 0.45% normal saline to infuse at 90 ml per hour for post-operative patients. If the tubing factor is 20 GTT per minute, calculate the flow rate in drops per minute. Okay, so drops per minute. So let's try this problem. Okay. So again, as you can see, we have the given. So the given is this. The drop factor is given. And then we want to end up with drops per minute. So in other words, you want to get to GTT, your wanted quantity is GTT per minute. That's what I want to arrive at, drops per minute. Okay. So let's do the same thing we did as above. Drop factor 20 GTT as per minute. Okay. And then our given, the doctor has ordered that you give the 1000 ml at the rate of 90 ml per hour. So that would be the rate ml per hour. They have to infuse 1000 ml of the normal saline. So let's start our setup. So let's start with the given quantity or the rate that has been ordered. So we say 90 ml per hour. So over 1 hour times, I'm going to factor in the drop factor. Okay. So that will be the conversion here. So 20 GTTS for 1 ml has to be ml here. This is ml. So to 1 ml. Okay. So let's cross out as we go on the units. So ml cross ml out. So far, my unit is in GTTS or drops per hour. All right, you can see that drop per hour. But I want to get to drops per minute. So I have to keep going. Change. Now I'm going to change the hours to minutes. Since the minute is in the denominator, I should have minutes here and then the hours here. And we know that 1 hour is 60 minutes, right? Let's cross out and see if you have the units correct. Hours crossed out. What do we end up with? We end up with drops per minute. Okay, so drops per minute. So we end up with GTT per minute, and that's what we want. You can see it. So now let's multiply out and reduce to lowest terms so that you can cross out and get your answer in lowest terms. Okay, so I can do this. 20 into itself is 1, 20 into 60 is 3, 3 into itself is 1, 3 into 90, so that's 30. So here you have 30 drops per minute as your answer. Okay, or you can just use a calculator to multiply out and get your answer. Okay, now let's try the last problem here. So Zivox 600 milligram IV once a day is ordered for a patient. The Zivox is dissolved in 30 ml of normal saline and should infuse over 1 hour. Using the tubing with drop factor of 20 GTT or drops per minute per ml, 20 drops per ml, how many drops per minute should the Zivox be infused? Okay. And we're given the label. That's the label over here. Okay, so there are certain important things that you have to look out for on every label. Okay, if you look at this, the important thing, you'll be given the concentration, 600 mg per 300 ml. This is very important. Okay. It's an important factor to look out for on the label. Okay, it's one of the rates that you're going to use, or the conversion factors that you're going to use. Okay. So let's analyze the problem. So you need 600 milligrams. That's the order for the Zivox. And then this dissolved in 300 ml of normal saline. And you're infusing that over 1 hour. Okay, we have the drop factor. This is given here. And what are we looking for? We're looking for drops per minute. So in other words, you want to end up with GTT per minute. Okay. So how can we get to GTT per minute? We have to start with the order that has been given. So we want to give 600 mg in 30 ml over 1 hour. Okay. So start with the 300 ml. You take the 300 ml, and that is given over an hour, so per hour. So that's the rate that has been ordered. You're given 300 ml in 1 hour. Okay. Then you know your drop factor. Your drop factor here is 20 GTT, drops per mil. Okay. So since we want to end up with drops per minute, it means that GTT has to be in the numerator. So 20 GTT has to be here per 1 ml. You can cross out the units, ml. So far you have GTT per hour, drops per hour, but you want to go to drops per minute. So you have to keep going. Now we're going to change the hours to minutes. And we know the conversion factor is going to be hours, 1 hour to 60 minutes in the denominator. Okay, so the hours will cross out. And then the answer is in joules per minute. Okay, that's what we'll end up with, joules per minute. GTT per minute. Right? They can simplify to lowest terms or use a calculator to do the problem. Okay. So the 620 itself, 120 here will be 3, 3 here is 1, 3 here will be 100. So your infusion rate will be 100 over 1, which is 100 joules per minute. Okay. So in this question, it's don't get confused, right? Don't get too confused. Some people wondering why didn't we use the 600 to work out this problem? Okay. Now, if we look at a label, if you have to infuse 300 ml, the 300 ml that you're infusing contains the 600 milligrams. You can see right there on the label. Okay. So in this question, we don't need to use the 600 milligrams here. Okay. Okay. So I hope you've learned something from these 3 questions. Tune more for more videos on dimensional analysis. Bye.